Okay, this is the final bit then of our complex number. So it's the nth roots of any complex number. We've just been through the nth roots of unity, as in all the nth roots of 1. And so this is just an extension then from this. So if you have a complex number, z equals r cos theta plus I sine theta, this can also be written as r cos theta plus 2k pi. I sine theta plus 2k pi, because anytime you put in 1, 2 and 3 in the k, you just go round in multiples of 2 pi. So, you know, 10 degrees is the same as 370 degrees. You're just adding 360 each time, or adding 2 pi because we're in radians. Because adding or subtracting multiples of 2 pi to the principal argument takes you to the same point where you started on the Argand diagram. The nth roots of z then are given by z1 over n is r cos theta plus 2k pi plus I sine theta plus 2k pi 1 over n. So that means you put the r, which is the number out the front, or the modulus of it, to the power of 1 over n, and then cos theta plus 2k pi over n, I sine theta plus 2k pi over n. By letting k equal 0, 1, 2, all the way up to n minus 1, you can obtain the nth roots of z. In exponential form, these will be r 1 over n, e to the I theta 1 over n, r to the 1 over n, e to the I theta plus 2 pi over n, theta plus 4 pi over n, and so on, all the way up through. So find the fifth root of 1 plus I. So what is it we're doing? We're trying to find numbers that whenever you multiply themselves by each other 5 times, you end up then with 1 plus I. And there's just kind of, we're just going to follow this wee technique then to try and do it. So hopefully that'll make sense to you. First of all, what does 1 plus I look like? If we draw it on the Argand diagram, 1 plus I is going to be then at 45 degrees, or pi over 4 going this way. That's the number 1 there, that's the number 1 there, and our angle then, as you know, then is pi over 4. So that's our z equals 1 plus I. The modulus of z, so the length of that line then, is going to be root 2, and the argument of z is going to be pi over 4, as we've just chatted about again. We can get that information then from there. If we write it then in our mod arc form, which is the way we want to do it, then z equals root 2, because that's the length of the line, cos pi over 4 plus I sine pi over 4. As we chatted about, we can rewrite this in the form. This seems a wee bit strange to start with, but it's just so we know it's the same thing. This is equal to the line above. That's cos pi over 4 plus 2k pi plus I sine pi over 4 plus 2k pi. This is this complex number just written in a different format, and we want to try and find the fifth root of that. So what do? Z then to the power of a fifth, you can see that okay, is going to equal root 2 to the power of a fifth. Why is that? Because what do we do here? We find this bit here, we put that at the power of a fifth, and then we're dividing then each of these by 5, and we're going to put the numbers 1, 2, 3, not 1, 2, 3, and 4 into this, and that'll be where we are. So we're on root 2. That's all then to the power of a fifth. Big square bracket, there's a lot going on here. Cos pi over 4 plus 2k pi all over 5 plus I sine pi over 4 plus 2k pi all over 5. If you're still with me. We're now going to let k equal 0, 1, 2, 3, and 4, and that'll generate then our fifth roots of our original complex number. So that's why we're going to let k equal 0, 1, 2, 3, and 4. If we let k equal to 0, then a root is root 2 to the power of a fifth cos So if we go 0 there, that wee bit disappears, and so we have pi over 4 over 5, so that's just going to be pi over 20. Plus I sine pi over 20. So that's our first fifth root. If k equals 1, then the root is root 2 to the power of a fifth. Okay, so let's see what we're going to have here. This gets a wee bit complicated. I'm letting k equal 1 here, so we have 2 pi plus pi over 4. I hope you can see that that's the same as 9 pi over 4, because 2 pi is the same as 8 pi over 4, so 8 pi over 4 plus pi over 4 is 9 pi over 4. 9 pi over 4 over 5 gives us then 9 pi over 20. I hope you're still with me. If we let k equal 2, we'll fit one more in here. Root 2 all to the power of a fifth, which is incidentally going to be 2 to the power of a tenth. We'll come to that. So we are subbing into here a 2. So that gives me a 4 pi, which over 4 is 16 pi, so it's going to be 17 pi over 4 over 5. So that's 17 pi over 20 plus I sine 17 pi over 20. I now need my next page. Let's see if we can negotiate that without too much pain. What did I have? 17 pi over 20. So our next one is if k equals 2. No, we've just done 2, haven't we? 3. If k equals 3, then a root is root 2 power of a fifth, because I'm putting the number 3 into it then, so it's going to be 3 instead of the k, so it's going to be 3 pi, which will be, goodness me, where are we? So over 4, sorry, 6 pi actually, so 6 pi then, if we're putting that over 4, it's going to be 24 then, plus the 125 pi over 20. Plus I sine 25 pi over 20. Give me a wee second here. Let's see where they are. And then if k equals 4, then my root is going to be root 2 the power of a fifth cos. So we have 8, 32, 33, is it? 33 pi over 20 plus I sine 33 pi over 20. And those then are our 5 roots. Incidentally, much like our diagrams, if you remember our diagrams, in fact here it is, it's just from the previous video. Remember these beautiful diagrams that I drew talking about the roots of unity? These ones for any complex number are quite similar. So if I was to draw this particular one, the first one, so here's our Argon diagram. The length of the line, first of all, isn't going to be 1, unlike the roots of unity. It's going to be root 2 to the power of a fifth. So it's going to be 2 then to the power of a tenth. That's going to be the length of it. And the first one that we have, what was the angle for that one? First one we had was pi over 20. So that then would appear just like this. So that would be the first one. And effectively, again, it's split exactly into 5. It just doesn't start at 0. So our next one then was, I think, what was it, 9 pi over 20? Let's think where that's going to take us to, maybe about there. and we end up again with our kind of pentagon type thing. I'm not going to be able to draw this here probably, but maybe something like that. Each of those are all the same length. The gap between them every single time is just going to be exactly the same. So it's going to be 2 pi over 5, or if you want 72 degrees. And then those are our 5 different roots. The fifth roots of 1 plus I. So they end up then looking like that. And I think that is pretty much us. I don't know if I wanted to add another piece of information to that, but I don't think so, but that's us. Anyway, that's where we are. Hopefully that makes a little bit of sense to you.